Hey there, Janet Math Chick Myers, and today we're looking at an advanced integration problem for a Calculus 2 class. So let's check it out. What I'm seeing right here is it really is going to lend itself to trig substitution, I'm thinking, because we have the square root of an a squared plus u squared situation. So let's scope it out. If we say evil plan, there may be more than one evil plan, but we'll find out. If we take a look at, do you see that 4x squared plus 81 is equal to 2x, the quantity squared, plus 9 squared? So I'm just going to write this as 1 over x times the square root of 2x, the quantity squared, plus 9 squared dx. So if we let 2x equal to a tangent theta, so a, remember, was 9. So what's going to happen if there's a couple things we'll need to do. Making our triangle, do you see that tangent theta is equal to 2x over 9? And using right triangle trig, we would have theta here. And remember that we would have the tangent is the side opposite over the side adjacent. So we'd have 2x opposite the angle theta, 9 adjacent. And if we did the trig substitution right, what's going to happen is we'll get the correct square root. So do you see this would end up being 4x squared plus 81. And we're good to go. Groovy? All right. So now if we take a look at, again, we have 2x is equal to 9 tangent theta. And so if I isolate x, we would have 9 halves tangent theta. And I'm differentiating with respect to theta. So I would get dx is equal to 9 halves secant squared theta d theta. Cool. And then what else am I going to need? For sure I'll need this one here. What's the square root of 4x squared plus 81? Well, that's equal to, well, we would have the square root of 2x squared plus 81. But what was 2x equal to? That was equal to 9 tangent theta squared plus 81, which, when you square it out, would be the square root of 81 tangent squared theta plus 81. Factoring out the 81, we'd have 81 times the quantity tangent squared theta plus 1, which is, I'm going to evaluate root 81 to be 9, and then we'll get the square root of secant squared theta. Good. So we'll get 9 secant theta. Cool so far? All right. Now we also need to find x, and we did, so we're good there. We'll be utilizing that. So let's now take a look at what it looks like once we do these substitutions. I know it seems to be very complicated, but sometimes it divides out to be quite simple. Okay, so now, here we go. This will be equal to the integral of, so our dx is over here, right? So I'll just write that in the numerator. So we're going to have 9/2 secant squared theta, d theta, over, and again, that was our dx. And then our x is over here, and that's 9/2 tangent theta. And then our radical, let's do in aqua, I guess. So the square root of 4x squared plus 81 is going to be equal to 9 secant theta. Isn't that cool? So this whole thing here, including the radical, is just 9 secant theta. All right, so one of these secant thetas divides out, the 9/2 divide out, and let's see what happens. So we'll have the integral of secant theta is 1 over cosine theta. We'll be multiplying that by the reciprocal, right? So that would be multiplying by 1 over 9 tangent theta. And then we still have our d theta. So that's going to be equal to 1 over cosine theta times tangent theta is sine theta over cosine theta, but they will invert and multiply. So I believe we would end up having cosine theta over 9 sine theta with a little algebra times d theta, or with respect to theta. All right, so now these cosine thetas divide out to be 1. So these were ones. And then now using the reciprocal identity, this will be, well, 1/9 is just the constant multiplier. And then times the integral of cosecant theta, d theta, which is nice because we'll end up getting negative 1/9 natural log absolute cosecant theta plus cotangent theta plus our constant of integration. And then we use our right triangle trig to find cosecant theta and cotangent theta. So this will be negative 1/9. Cosecant theta will be the hypotenuse over the side opposite. And so we'll have the square root of 4x squared plus 81 over 2x. And then cotangent theta will be the side adjacent over the side opposite. So we'll have 9 over 2x plus our constant of integration. And then this will be negative 1/9 times the natural log of absolute. Do you see they're both over the same denominator? So we will have 9 plus the square root of 4x squared plus 81 over 2x plus our constant of integration. And we're pretty much done. I mean, you could play around with some properties of logs, but it's not going to make this expression much nicer. So just go ahead and box your answer, and we'll be happy we're all done. All right, so I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. And hey, if you like what I'm doing, please subscribe and tell your friends. Bye.